Hello and welcome to Unit 8, opener number 6. We have a challenge problem here, and that is we're supposed to come up with two numbers whose sum is 17,284.74 and whose difference is 7,494 and 88 hundredths. But before we do that, we're going to try to solve this simpler problem, and that is we're going to name two numbers whose sum is 14 and whose difference is 2. So we're going to really focus on this problem for most of this video. So we're going to look at several different methods for solving it, and we're going to talk about why that method may or may not work well to solve this challenge problem. The methods we're going to look at are guess and check, graphing, and then we're going to look at something called substitution, and something that we're going to call Y to Y substitution, which, as you might have guessed from the name, is really just a special case of substitution. Alright, well, we'll start at the beginning here, and we're going to define two variables because we're looking for two numbers. So I'm going to let X stand for one of the numbers, and I'm going to let Y stand for the other number. Nothing too fancy. And I'm going to write these two equations. The sum of the numbers is supposed to be 14, so that means X plus Y is supposed to add up to 14. And the difference of these two numbers is supposed to be 2. So I'm going to write X minus Y equals 2. By the way, in terms of defining our variables, you may notice if I'm writing the equation X minus Y equals 2, I've actually sort of decided which of the two variables stands for the greater number. And so if I'm doing X minus Y and getting a positive number, that means X must be greater than Y. I'm just going to stick with my definitions up here of one of the numbers and the other number. Okay, well, guess and check. Sure, I could solve this using guess and check. Let's see. If I'm going to use guess and check, I'm at least going to use a table while I do it. And here's what I'm going to do. I'm going to pick a number for X, and then I'm going to use that to pick a number for Y, and then I'm going to check in the second equation whether or not it really equals 2. Okay, so I'm just going to randomly pick a number for X, and I'm going to choose 7. So now I'm going to use the top equation. 7 plus what equals 14? Well, 7 plus 7 equals 14. But now if I do 7, so notice by picking this 7 and this 7, I've made the top equation true. Now all I have to check is whether or not I'm also making the bottom equation true. So X minus Y, 7 minus 7 is 0. I was supposed to get 2, so that didn't work. So I try again. Maybe I'll make X be 5 this time. Well, 5 plus Y is supposed to equal 14, so it has to be 5 plus 9 would give me 14. And now if I do 5 minus 9, I end up with negative 4. But I wanted to end up with 2. Not only am I not at the correct answer yet, but you'll notice from my first guess, I've actually gotten further away from the answer. So I don't want to make X smaller. I want to make X bigger. So let's try a number bigger than 7, like 8. If 8 plus Y is 14, that means Y has to be 6. And if I do 8 minus 6, I get 2. And that is what I wanted to happen. So I found the solution. The solution is 8 and 6. Now, the big question though is, would this be a good strategy for our challenge? And I hope you can agree with me that, my goodness, this would be very, very difficult using these numbers. It wasn't so hard with 14 and 2, but I think it would take a great many guesses using these two numbers for the sum and the difference. So I don't think I'm going to bother writing this down. I'm hoping it is so blatantly obvious to you why that's going to be a bad strategy. It's just going to take too much time. All right, next we could try graphing. I've got x plus y equals 14. Let me drag my equations down here. Okay, x plus y equals 14 and x minus y equals 2. So I can graph these pretty quickly and easily. The top one, I'll graph the top one in blue, and if I use the intercept method to graph it, if x is 0, y has to be 14, and if y is 0, x has to be 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is here, 14 is here, and I connect them. You'll notice the slope of the line connecting them happens to be -1. Okay, and then I'll use red to graph the second line. Again, I'm going to use the intercept method. If x is 0, 0 minus something has to be 2. Y would have to be -2. And if y is 0, x minus 0 has to be 2. That means x has to be 2. So here's this one. This one is going to have a slope of +1. And the two lines intersect right there at that point, which is the point, let's see, 1, 2, 3, 4, 5, 6, 7, 8 for x, and 1, 2, 3, 4, 5, 6 for y. So here's the good news. We got the same answer we got the first time using the first method. The solution is still 8, 6. But do we think this is a good way to solve our original challenge problem, which, remember, involves these huge numbers and some decimals? And again, I hope it is blatantly obvious to you that graphing would be a poor method, at least graphing by hand would be a poor method to solve the challenge problem, because graphing by hand is only going to work when the solution happens to be a nice, we call it a lattice point on the graph, a nice integer, easy to see on the graph. So for one thing, the answer to our challenge problem is probably going to be a decimal. And not only that, it's going to be a huge decimal, I would guess, given that the numbers are in the thousands. So we're going to be drawing this graph where, we're going to have to go up very high to 10 or even 20,000 on the sides of the graph. And then the two lines are going to intersect somewhere in there. It's not even going to be a whole number, so I don't see how we could possibly find them using a graph by hand. Now, if we had a computer graph it for us, and the computer could find the intersection, fine, or a calculator. But it's not going to work very well for our challenge problem.